Hello and good evening, CSI258 students for the fall 2014 semester at Anne Arundel Community College. This is the second of two courses for the Cisco Networking Academy. And the first PacketTracer tutorial we're going to be taking a look at this evening is PacketTracer Skills Integration Challenge 1.4.1.2, which focuses on OSPF. And as you can see over here on the right-hand side, it focuses on a little bit more than just OSPF. Quite a few configuration tasks that need to be done. So let's go ahead and let's jump right in. So the addressing table is quite large, and we're going to be dealing primarily here with routers 1 and 4. So let's go ahead and start at the top here, basic device configuration. So configure the following on R1 and R4. So we're going to set device names, we're going to set the encrypted privilege exec password, the enable password. We're going to set up a banner MOTD. We're going to use the addressing table to fill out the IPv4 and IPv6 addresses, and then we're going to assign the link local addresses to each interface. So let's go ahead and we'll start with R1. And again, the majority of this will be review. So we'll come to the CLI here. And we'll go from user exec to privilege exec, and then from privilege exec mode we're going to move into global config mode. So the first thing we'll configure will be the host name, which is just simply going to be R1, and then we're going to go ahead and set the enable password. So the enable, and we want to make sure we do the enable secret, right? And we're going to go ahead and use Cisco as the password. Okay, the next is to set the banner. So it's banner MOTD, and then we put a character here, and that character signifies both the beginning as well as the end of our banner message. So we want to make sure we keep the word warn, W-A-R-N, in our banner message. So log off now if you are not authorized. Oops. This is your warning. We'll say warn. Alright, so now to end our message, we simply use the same character that we used initially from global config mode, which is the hash sign or the pound sign. So now we have our banner message of the day. And now we're going to go ahead and set the IPv4 and IPv6 addresses for router 1. And there are quite a few interfaces here. So we'll start out first with gig 00. I'm going to bring that interface up right away. That is the LAN interface. And as you can see here, Spanning Tree is doing its thing, and so this link will turn green here shortly, but we've just activated the LAN interface, gig 00. So our IP address here is 10.10.10.1 with a subnet mask of 255.255.192 or a /26. We're going to go ahead and put the IPv6 address as well, which is going to be 2001:DB8:A:10:1/64. So our prefix is a /64. Remember, it's not a subnet mask. It's referred to as a prefix, the prefix link. Okay, and then finally, we're going to go ahead and do the IPv6 link local address, which is FE80::1. And again, you do not specify the prefix link here, or prefix length. IPv6 address, apologize there, IPv6 address, FE80::1, and then link local. So again, for the link local address, we don't need to specify the prefix length. And for the global unicast address, which is our 2001:DB8:A:10::1, we do specify the prefix length. Alright, so that takes care of our IPv4 address, our IPv6 address, and our IPv6 link local for gig 00. Let's go ahead and jump in on serial 000. Let's bring the interface up. Make sure we have that up right away. And let's go ahead and get our IPv4 address on here. So IP address, and it's going to be 64.102.139 255.2, and our subnet mask is 255.255.255.0 or /24. Let's get our IPv6 address on here, and that's going to be 2001:DB8:64:2/64, and then our link local, again, it's showing the link local for FE80, IPv6 address, FE80::1 for the link local, and so we'll configure that as well. Alright, so that takes care of serial 000, and that's actually our interface out to the internet. Now let's jump into serial 001. We'll go ahead and bring that interface up right away, the no shut, and we're going to assign the IP address of 10.10.1.1, and this is going to be a /30, whoops, 255, pull that back up, 10.10.1.1.1, so 255, 255, 255, 252, and we've also got an IPv6 address, which is going to be 2001:DB8:, and where are we at? B:1:1/64 for the prefix length. And then we've got our link local address, IPv6, ADDR, FE80::1. And just to remember that the FE80 that we keep using here, remember that is a link local address. So we can actually have this address, and this is what we're doing, on every interface on the same router, because again, it is locally significant to the link on the router, right? So you can even think of it in terms of to the port on the router, it's locally significant, and that's why we're able to reuse that address over and over again on R1. And then, let's come back up here. All right, and then finally we'll end up with link local. So we've got our link local address configured there. And then last but not least, a number of interfaces here. Serial 010 is going to be the next interface we configure. And we're going to bring that guy up right away. Assign the IPv4 address, 10.10.1.5. And this again is a 255.255.252. So it's a /30. We'll get the IPv6 address on here. It is 2001:B:2:1/64. And then we'll put our link local address on here, which is also going to be FE80::1 with the link local specification. Alright, so that concludes all of the IP addressing for router 1. There's quite a bit of IP addressing going on there. Okay, and so now what we want to do is we're going to go ahead and I'm going to save my configuration here just to make sure. And we're going to pull up router 4 now because we need to do a number of tasks similar to what we did on router 1 to router 4. Alright, so we'll go from user exec to privilege exec in the global config. I'm going to set the host name of the router to R4, and that's per the addressing table. We're going to go ahead and set the enable secret password to Cisco. We're going to set the banner MOTD message of the day, and I'll use the hash sign again, and log off now. You have been warned. I'll just put warned, just in case it's not looking for anything following or preceding that WARN. And then we end it with the same character that we used at the end of the banner MOTD command. So now we have our MOTD created, and we're going to do some of the addressing. So int gig, actually let me do a quick do show IP interface brief. And not actually do that. Okay, good. So all these interfaces are down, nothing's configured. And let's go ahead and we'll go into int gig 00. And we're going to set the IPv4 address. So IP address for gig 00 is 10.10.4.1, and this is a /24, so 255.255.255.0. And did I do a no shut here? Let's make sure we do a no shut. That way I don't forget. So IPv6 address is going to be 2001:DB8:A:4:1, with a prefix length of /64 or 64. And then the link local address, IPv6 and it's going to be FE80::4. We need that link local designator there. Okay, so we've got the link local address configured, and the IPv6 address and the IPv4 address for gig 00. Now let's transition to serial 001. We'll do the no shut and make sure he comes up. And this is our internet-facing connection, so IP address is going to be 64.103.17.2, and it's a /30, 255.252. And then we need an IPv6 address. So IPv6 address for this link will be 2001:DB8:, and it's going to be A:103, whoops, A:103:DB8 A:103:2/64, and then our link local address will be the same as it was previously, FE80::4 for the link local address. All right, and so that takes care of the addressing configuration on, or the basic device configuration on R4 and R1. So let's do a quick checkpoint here. We'll save our configuration. All right, you always want to make sure you save your configuration often. Okay, so now on to the next phase, right? So we did the basic device configuration. Now we're going to take a look at the SSH setup. And again, this should be review. So we're going to configure SSH on R4. We're going to go ahead and set the domain name. So we're going to go into global config mode, and it's IP domain, domain-name, and we're going to set the domain name, set a domain name of R4. All right, so we are setting the domain name to just R4. All right, so we'll hit enter there. Create a user admin with an encrypted password of Cisco. So we're going to add a user here. So username admin, and then we want to go ahead and do a password. But do we just want to do password, or do we want to do secret? So chances are you're going to want to do secret. That way you get an MD5 hashed password as opposed to a type 7 password. And again, as reviewed, type 7 passwords, very, very easy to crack. You can actually Google how to crack type 7 password, and there are multiple sites where you just cut and paste the password into the web page, and it'll give you what the password is set to. So we're going to do it as secret. Okay, and so it's going to be Cisco, right? So username admin, and then secret Cisco. And so if I do a do show run right now, you can see the enable secret command is definitely an MD5 hash. And let's take a look at our username. I think I may have went right by it. So there's the username. We went right by it, but you can clearly see that it's much more complex than a type 7 password. Okay, so we've got the username created, and now it says create a 2048-bit RSA key, so it's crypto key generate RSA, and we're going to hit enter. It says you already have an RSA keys defined. Do you really want to replace them? We're going to go ahead and say yes. And how many bits? 2048. All right. So it's created the new keys for us, and then we're going to configure all VTY lines to use SSH and a local login. So line VTY 015. So login local, and remember, login local means you have to have a locally configured user on the router, or else we're, from the remote lines anyway, from telnetting in or from SSHing in, which is what we're going to do here, you would be locking yourself out of this router if you did not have a locally defined user account. But we do, and we created it earlier in this phase, and it's admin. So for SSH, it's transport input SSH, right? Now remember, you can do all, you can do none, you can do SSH or telnet, so we're just going to do transport input SSH. All right, so we've got SSH set up on our VTY line, so we're good there. All right, let's come down and take a look at what we're being asked to do next. And again, this is focusing here, it looks like, primarily on router 4. So now we're going to do some DHCP configuration, right? We're going to have router 4 go ahead and pull up, where is desk scribble? It's on here somewhere. There we go. So we'll pull desk scribble up here so I can make some notes. And slide this guy all the way down to the right. All right, so what we're going to be doing in this step here is we're going to be setting up DHCP. So primarily, this router interface here will be providing, or this router through this interface is going to be providing DHCP services to the hosts down here, PC5 and PC6. And from looking further down, you can see where we're actually going to be doing some configuration on PC5 and PC6. All right. So we'll jump back to the regular cursor here. So configure R4 to act as a DHCP server for its LAN, and that's through switch 4 to PCs 5 and 6. And we're going to create a DHCP pool using the name R4. So IP DHCP pool, and then the name of the pool, which is, in our case, just going to be R4. All right, so it says assign the appropriate addressing information to the pool, including the 209.165.44.2 as the DNS server. All right, so what settings can we set? We can set a default router. We can set the DNS server, which they've just provided us that IP address to the right. We can set the network mask, and then there's some other options. So the first one we're going to do is we're going to set the network, okay, and it's the network number, and in our case it's going to be 10.10.4.0, and then the net mask is going to be 255.255.255.0, so the whole /24. So what we're saying here with this command is that the router is going to provide DHCP addresses starting from 10.10.4.1 all the way up to 10.10.4.254. Now, you can see the final step here says prevent the address used by the router from being distributed to end devices, and so we're going to address that here in a second. All right, so we've gone ahead and declared the network that we're going to use. We also have been given the DNS server we should use, which is 209.165.44.2, and we're also going to set the default router because we already know that the R4 gig 00 interface, which would be, this would be the default gateway that we would set on these PCs here, but however we're giving DHCP out, so we need to have some way of telling those PCs, hey, this is your default gateway, so we're going to set that right now. 10.10.4.1. All right, and so we've got that set up as well. So we've got DHCP set. However, the one thing that we did not do, and let me exit out here, is we didn't address preventing an address from being distributed via DHCP. So IP DHCP excluded address, and you can see here you can exclude a range of addresses, but we're just going to be excluding one, which is 10.10.4.1. And you can see you can go up to a high address. So we just want to exclude that one address. And that's the address that's being used by the default gateway. All right, so that takes care of the DHCP v4 settings and configuration, and now we're going to move down into the NAT configurations, and I'm actually going to pause here for a second to get something to drink, so stand by. All right, I'm back. I'm sorry, I was a little hoarse there, so I want to get something to drink. Okay, so we've got the NAT configuration piece, which is going to be next here. And so it says configure NATPAT on R4 so that all devices on the LAN use the IP address on the serial 001 interface to access the internet. And so now we know that the IP address on that interface for R4 is the 64.103.17.2. So if you remember back 2 courses back to the 158 course, the Routing and Switching Essentials, where NAT was covered, you'll remember that there are 2 ways that you can do PAT, Port Address Translation, or NAT overload. And the first is to use a pool of addresses where you have multiple inside global addresses that are available to your inside locals. And then the second way to do the NAT overload, or the PAT, would be to use a single inside global address, which is what we're doing in our case here, which is that 64.103.17 address. and have that service all of your inside local hosts. Okay, so it says use a single statement in access list 1 to define the addresses that will participate in NAT. So this is very straightforward. So it's just simply access list 1 permit, and which IP address range are we going to be permitting? And that's going to be everybody on the local LAN. So 10.10.4.0, and then obviously we've got our wildcard mask here, 0.0.0.255, because again we're dealing with a /24, so that is the wildcard mask. So that's the access list that we're going to use later on here when we declare our IPNAT source list, and that's where we're going to put that access list to work. Okay, so it says enable NatPat using the access list. So the first step when we're configuring port address translation or NAT overload is to create that standard access list that dictates the hosts that are going to be able to use NAT. So the second step that we want to use is we want to go ahead and configure that source translation using the access list number. So it would be IPNAT inside, and then we're going to go ahead and put source list, and this is where we put in our access list number. And so in our instance here, the access list number is 1, and then this is going to be followed by the interface. Okay, because remember, we're not, and this is the difference here. So, and this is really the two ways to do NAT overload or port address translation, is either use a specific interface or provide a pool of addresses to be used. So clearly they're asking for us to simply do the port address translation with a single IP, which is on that serial 001 interface. So I would say interface, and then it's going to ask for the type, right? So we're talking about serial 001, and let's confirm that. A lot of interfaces in this activity. Yeah, serial 001. And then that's going to be followed by overload, right? And so that's the key. When you put overload in there, that signifies that we're doing port address translation or NAT overload. You'll remember when you're doing dynamic NAT or when you're doing static NAT, that the overload keyword is not added to the IPNAT source list or the IPNAT command. It's added when we're doing NAT overload or port address translation. And again, remember, those are synonymous terms. So when I say PAT or port address translation, that's synonymous or the same thing as NAT overload. Okay, so there's our command: IPNAT inside source list 1 interface serial 001 overload. So I'm going to go ahead and I'm going to hit enter. And the next step, right? So the first step is the access list. The second step is to go ahead and configure the translation using the access list and signifying the interface that we're going to be using. The next step is to identify the interfaces that are going to participate. So on the inside, we know that gig 00 is going to be our inside interface. So IPNAT inside, because that's where the clients are going to be coming from, and then int serial 001 would be IPNAT outside. And that's the outside interface on the router that's providing NAT services. Okay, so we've got NAT configured there. Let's double check here. So use a single access list, we did that. Only allow that specific address space, we did that. We enabled NatPat using the access list and configured the interfaces for inside or outside. All right, so that looks like they're wrapping up on router 4. So let's do a write mem and save our configuration. And now we're going to be doing some additional natting over here on router 1. And you see when I transitioned from user exec mode into privilege exec, I was prompted for the password, and this is the MD5 password, that was the secret password we created with the enable secret and the password. So it's good to see that that's working. You can also see that our banner message of the day is also being displayed. So 2 good checks right there as we transition into privilege exec mode. So let's take a look. It says configure PAT port address translation, or NAT overload, on router 1. So use a single statement in access list 1 to define the addresses that will participate in NAT, and it says only allow the 10.10.00/16 address space. So again, very simple. Oops, got to get in the global config here. So very simple access list command. So access list 1 permit 10.10.0.0, and our wildcard mask will be 0.0.255.255. And so again, very straightforward, very simple standard access list that we want to add to our configuration to say only hosts in this range are going to be able to use the NAT functionality that we have set up. And if you take a look at R1 here, and I'll drop those into the background, it's interesting. Over here, we use the /24 because on R4, you could see on R4 we had a single /24, right, with just a couple of hosts down here. So, but behind R1, when we take a look at R1, R1 has an interface here that shoots out to R3, and so you've got the 10.10.3, you've got the 10.10.2, we have the 10.10.10, and so that's why when we're taking a look at the single statement that's going to be used, they've opened it up a little bit to basically say it's 10.10 anything, right? So 10.10.1, 2, 3, 4, 5, all of that address space is going to be able to use or leverage NAT services on router 1. And so these will be our inside local addresses, right? I shouldn't say inside local addresses, I apologize. These will be our IP NAT inside interfaces is what I wanted to say. So these are your IP NAT inside interfaces, and this guy right here, as he heads out to the internet, and that is going to be our outside IP NAT outside interface. All right, so let's jump back into the configuration piece here, and I'll pull router 1 back up. Okay, so we're on router 1, and we've got our access list created, and so it says define a pool named R1. So we're actually going to be defining a pool here, because remember, there are two different ways that you could do port address translation or NAT overload. And the first we just did over on the R4 LAN, on router R4, where we indicated an individual specific interface, a single interface. So here what we're going to be doing for our inside global assignment is we're going to be using a pool of addresses. And so it says define a pool named R1. So IP NAT pool, and then the name of the pool. So our pool will be R1. And then after we do IP NAT pool R1, it's telling us that we're going to use all 4 addresses in the 64.102.139.4/30 address space. All right, and so what we're going to do here is we're going to go ahead and say, whoops, space in there. So our starting IP is going to be 64.102.139.4, and in a /30 we know we've got 4 addresses, and so this is going to be 4, 5, 6, and 7. So it'll be 64.102.139.7. And you'll notice, if we scroll back up here on router 1, you can see that our link out to the internet is actually, it's actually a /24, right? So there are 254 possible IPs, assignable IPs that could be used. However, we're simply trimming this down to say, with this /30 down here, is we're just saying that we're going to be using these 4 addresses. All right, and so then it's going to be 64.102.139.7, and then what's going to follow is the netmask command, and our netmask is 255.255.252, because again, the netmask that we're using, even though this address space is within that /24 that's assigned to this link, the netmask value is not the same /24, because we're not saying we're using all 254 addresses. We're saying that what we're doing is we're going to be creating a pool simply of 4 addresses, and so it would be .4 to .7 inclusive. And don't confuse this with .4 and .7 being the network ID and the broadcast address, because that is not the context in which those are being used here with the /30 mask. So these are all assignable IPs, and so this is how we would pick off a specific range of IPs that we wanted to use. All right, so we've got the command typed in there, and that should be everything. So we're going to go ahead and hit enter here, and then move on to the next step. So it says define a pool, which we just did, and then assign access list 1 to the pool R1. And so the next step here, so again, the first step is to do the IP nat pool command, or you could create your access list. We'll keep it in line with what we did previously on router 4. So again, first step, very simple access list. Which networks are you going to permit, and which networks are you going to deny? And then the second step is what we just did right here is the IP nat pool, right, all the way down to the net mask of the pool of addresses we're going to allow to be used on the outside interface, right, or I should say our inside global address pool. And now I'm going to go ahead and associate the access list. So we've got IP nat inside, source, and list. And so this is where we would say access list 1, and then we're going to associate that access list to the NAT pool that we created previously, which was our previous command right up there. You can see it, the IP NAT pool R1, right? So it was right here. So we're associating this access list, which basically says the range of addresses in our access list, those addresses and those addresses only are going to be allowed to use these 4 inside global IP addresses in order to gain internet access. And so we've got pool, and our pool name was simply R1, and then we're going to say overload, right? Because again, we're doing NAT overload or PAT. We're just doing it a different way than we did it with router 4. And so I'll go ahead and hit enter. Okay, all right, configure the appropriate interfaces as NAT inside or NAT outside. And so again, R1, a little more going on here with R1 than with R4. So R1 is going to have conceivably 3 different networks that could be coming through R1 that we want to go ahead and allow NAT services to be provided for. So we're going to do show IP interface brief, and we'll get gig 00, right? So IP NAT inside, and remember this is on the inside interface of the router that's providing the NAT services, right? Or the NAT functionality. These are the interfaces on which we're going to allow those services to be provided. So you can also see we've got serial 001, so IP NAT inside. And we have serial 010, IP NAT inside. And this is why, again, when we configured that access list that we used, we expanded our space, right? We did a /16. So a 10.10.0.0/16. So it's allowing all of the networks that sit behind R1 to participate with that NAT functionality. All right, so we've got all of our IP NAT inside. So then last but not least, we're going to go to serial 000, and we're going to say IP NAT outside, because that is the outside interface, and that's the interface where we want to have that translation take place from an inside local address to an inside global address. And so we'll say IP NAT outside. All right, and so we are still on R1 here, and we are in serial 000. So the next thing that's being asked for here is configure static NAT. All right, so let me say exit out. So configure static NAT on R1 for remote access to the intranet.pka server, right? So you can see here we've got the intranet PKA server, which is 10.10.10.10. However, that's an RFC 1918 address. That's a private address. So we need to make sure that hosts that are out here on the internet, when they try to come in to access that server, that they can get access to that server at the same IP address every single time. And so what we're going to do now is, and you'll notice that we used the 64.102.139.4/30 for our dynamic NAT, I apologize, for our NAT overload or our PAT setup. We started at .4, and now we're going to pick off the .2 address, and we're going to use some ports as well. So when doing the static translation, remember that the static translation is used when you want to make sure that the IP address on the outside stays the same, and that that IP address on the outside corresponds to the same IP address on the inside each and every time. And so that's why they use a web server as an example, because it would certainly be inconvenient if every time you wanted to go to a web server you had to type in a different IP address, right? And so that's why we want to maintain that relationship, and that's what we're going to be doing here with our static NAT configuration. And static NAT, as opposed to dynamic NAT or NAT overload PAT, is very straightforward, and it's, again, it's a one-to-one relationship. So what we're going to go ahead and do is we're going to say IP NAT inside, and we're going to use the source, and you can do a list, but we're doing static, right? And so here's where we would say IP NAT inside source static, and now you can also see here we've got the inside local IP address option, TCP and UDP options. So if we look over to the right, you can see it's asking for TCP port 80 traffic and then 443 traffic. So we're going to go ahead and say, let's come down here. We're going to say TCP, and so my inside local is 10.10.10.10. If I do the question mark, you can see, now give me the local port. And so that port is going to be 80. And then what's my inside global address? That's going to be the 64.102.139.2. And then we're also going to have to provide the global UDP TCP port, which will also be 80. And then we'll hit enter. And what I'm going to do is recall that command, and we're going to say, back up over now, say 443. And we'll come back here and say 443 to go ahead and configure the HTTPS functionality to allow that to be able to get through along with just the basic HTTP. All right, and so that is pretty much, we've already done, if you remember, we already did the IP NAT inside and the IP NAT outside on the interfaces in question, right? So gig 00, which is the interface behind which the intranet PKA server here resides. So we already have our NAT, IP NAT inside here, and then the serial 000 interface out to the internet also already has the IP NAT outside. So from this perspective, we're done with this task right here. So that is your static NAT configuration. Again, very straightforward, very simple. No access list involved, right? No pool. It's a one-to-one relationship. Okay, and so let's make sure that we've got that correct. And we do. Okay, so default routing. So it looks like we're going to be staying on R1 here. It says configure an IPv4 default route using, excuse me, using the next hop IP address 64.102.139.1. So IP route, and again, this is a default route, so the quad zeros, right? And then we could put an interface in here, but it's actually asking for an IP address, or indicating we're going to be putting an IP address in. So 64.102.139.1. So that statement says that our default route is going to be out the 64.102.139.1 interface, and we already know that that interface is right here. It takes us out to the internet, and if we looked at R1, you can see that we're 64.102.139.2, and so this is our next hop, right? Okay, So we've got our next hop default route in here. Now it wants a default route as well for IPv6, so IPv6 route ::/0, and it wants us to use the interface, and we know that the interface is serial 0, 0, 0. All right, so we've got our IPv6 default route configured as well. And so for right now, it looks like we are going to transition here over to R4 quickly. So let me pull R4 up for one setting. So we're going to go from user exec and a privilege exec, and you can see that our enable password is working. And from privilege exec into global config, and we're going to configure an IPv4 and IPv6 default route using the exit interface. So if I do the do show IP interface brief, you can see that our exit interface is going to be that serial 001. So IP route, do the IPv4 first with our quad zeros, and it wants us to use the exit interface. So serial 001, and that's okay. You're going to get a warning message there. It says default route without gateway. If not, a point-to-point interface may impact performance because there may be some recursion involved. So now we're going to do our IPv6 default route. So IPv6 route ::/0. Whoops. And it goes out interface serial 001. All right, so for R4, it looks like that wraps up our tasks on R4, and we're going to transition here now back to R1, where we've got a lot of activity going on here. So on R1, we're going to configure Ospf v2 area 1. So we're going to go into global config, and we'll go into router subconfiguration mode, or router configuration mode. So the process ID is going to be ID1. It says advertise directly connected networks do not include link to the internet. And so I could say, oh, whoops, I'm not going to redistribute. I could say passive interface, and we're going to go ahead and we'll set that on the interface to the internet. So passive interface, and that interface is serial 000. Let me double check that, make sure. Yep. All right, so we're going to do a passive interface on interface serial 000 because we don't want OSPF advertisements going out. And we're going to advertise directly connected networks. So let me roll back here. And we're going to get network 10.10.10.0, and the network is going to have a wildcard mask of 0.0.0.1, so 255 from 192. So we're looking at a, struggling with the math here. So let me come over here real quick onto my notepad. So again, our net is we have a /26, right? We need a wildcard mask for the /26, and we know that it would be a 255 for a /24. If it was a /25 with a 128, it would be a 127, and with a /26, it's going to be a 192. And so you simply take that from 255 to get the wildcard mask value. And so we're going to end up with 3, and then 9 from 15 is 63, and so that is going to be our wildcard mask value. I apologize there, I'm trying to blank. 0.0.0.63, and that is going to be in, let me confirm, area 0. Yes, area 0. Okay. So we're going to add that interface in, or add that network in, I should say. All right, so the next network we're going to add in is going to be 10.10.1.1, or .1.0. And the wildcard mask for this one's a little easier for me. It's just going to be 0.0.0.3, and he's going to be in area 0. And you can see a neighbor relationship just started there. So the next network is going to be 10.10.1. Actually, we just did, 10.10.1.4. And that is going to be another /30, so 0.0.0.3. And we're going to place them in area 0. And we should also see an Ospf adjacency established on that interface as well. And so that takes, and there it is, and that takes care of the router 1 interfaces. Excuse me. All right, so prevent routing updates from being sent across LAN interfaces. So we're also going to do passive interface gigabit 00 because we don't want the OSPF advertisements being pushed out onto that LAN interface, or out through that LAN interface. All right, let's see what's next. So we're going to propagate a default route. So it's going to be default information originate. And so that's going to send the default route information into the OSPF routing domain. And the router, or I'm sorry, I think I skipped down one there. Oh, propagate the default route, we did that? Okay, great. So now it looks like we're configure OSPF v3. Excuse me. I think I'm definitely coming down with a sore throat. Okay. So next we're going to configure OSPF v3 area 0 on router 1. And so what I'm going to do there, let me get out of that. So it's going to be IPv6 router, and then OSPF, and then my process ID. And so for the IPv, or the OSPF v3, we're going to use router ID 1. And there you go. We have not enabled IPv6 routing yet. So IPv6 Unicast routing, let's get that turned on. And I'm also probably going to take a look over here on router 4. I'm not confident that we have that on, so let's make sure IPv6 Unicast routing on router 4, and we got some points for that, so that's definitely something we overlooked. And now that the routing is turned on, I'm going to go ahead and do the IPv6 router OSPF1, and we're going to go ahead and create that. It says assign 1.1.1 as the router ID, and so we're going to go ahead and do that right there. So the router ID is being set to 1.1.1.1. Prevent routing updates from being sent across the LAN interfaces, so passive interface gigabit Ethernet 00. And complete any required OSPF v3 or IPv6 routing configurations. And so we're going to come back to that as I'm kind of reading ahead here at the same time. So configure PC5 and 6 to use DHCP for IPv4 and auto-config for IPv6. So that's some low-hanging fruit. So let's jump on that right now. So DHCP here. So I'm requesting an address, and we've successfully set that up on router 4. So we're looking good here. We're going to say auto-config here, and we immediately get our default gateway as well as an auto-configured address for PC5. And now let's pull PC6 up. Whoops. I always want to click on config. All right, so we'll say DHCP. Is DHCP working? It is, and as you can see, there's the DNS server value that we had previously entered in when we did our DHCP configuration on router 4. Here's the default gateway setting, our subnet mask, and we've picked up an IP address. And so now we'll come down and we'll say auto-config here. All right, and so there you have it. Okay, so it says complete. Well, I want to come back here to this OSPF v3. So as you can see here, right, we're at 100 out of 100. However, we've got this one step where it says complete any required OSPF v3 or IPv6 routing configurations. And we're going to go ahead and test connectivity here. So verify web access to the internet.pka and intranet.pka from each of the 6 PCs. So be sure to test both IPv4 and IPv6. So let's do some tests here real quick. And let me actually clear off. We're going to get that cleared out of there. Let's test from PC1 and let's see where, whoops, let's see where we can go. So if I were to say ping 10.10.10.10, is it going to work? He's probably going to have to ARP out because that is not on his local segment, and so as you would expect, it's not a network that PC1 knows about, so he sends out an ARP packet to get his default gateway MAC address, and then the subsequent packets work, and so if we pinged again, they're going to work right away until the ARP entry times out for that default gateway. Okay, so we can ping there. Can PC1 ping, and I think we want to try to ping the internet.pka. So I'm going to go ahead and say ping 209.165.44.2. And as you would expect, we're going to go ahead and get timeouts, and then we get the replies back. So the PC can ping out. PC1 can ping out anyway. Let's come over to PC3. Because if 1 can get out, chances are 2 is going to get out. So let's check 3, see if we can ping out here. So ping 10.10.10.10. And he's able to get out immediately. And what if I try to ping the IPv6 address? So 2001:db8:A:10:10. And let's see what happens here. So PC3's first attempt times out. His second attempt times out. And then the subsequent attempts are going to continue to time out. And so this step right here, this complete any required OSPF v3 or IPv6 routing configurations, this becomes critical. Because as you can see, I should be able to ping from PC3 to to intranet.pka. What if I pull PC1 back up and try to ping 2001:db8:A:10:10? And if you're actually doing this activity and following through, doing it for more than just to get to the 100 out of 100, as soon as you go to test your connectivity and you do the IPv6 connectivity testing, you should notice immediately that there's a problem. And as you can see, PC1 is also unable to ping as well. So let's take a look. Let's see if these guys even have IPv6 addresses, and they do. And their gateways are correct. So theoretically, even though we're 100 out of 100, we're missing some configuration information here. And so let's go back to R1. We turned on IPv6, and we also established the OSPF v3 process ID. And so there's our IPv4 settings, right? And you can see we have several network statements. And here's our IPv6 setting, where we simply say IPv6 router OSPF1, we put the router ID in there, log adjacency changes, but we don't have much else happening other than that. So what are those other steps that we need to do? And let me actually do the do show run again and get past where we were at there. So as we scroll up here, you'll see that we've got our passive interface, and that's great, but we've got these two interfaces here that we know we've got OSPF v2 or IPv4 OSPF adjacencies on, but we don't have do show IPv6 OSPF, right? You can see we've got some information there. We've got some, neighbors. See, we have no neighbors for IPv6, but if I do a do show IP OSPF neighbors, we've got a neighbor relationship with both router 2 and router 3. So how are we going to solve this? So let's do a do show IP in brief. I want to double check my interfaces here, make sure we've got it. So we're going to go to interface serial 001, and if I type in IPv6 OSPF, and you can see the process ID, we're using process ID 1, area 0, right? And I hit enter, is this going to bring up an OSPF adjacency? It does. So as you can see, there was some OSPF configuration that still needed to be done. And so now I'm going to go ahead and transition to, and if you can believe this, I forgot the address already, serial 010, the internet interface. So interface serial 010, and we're going to do that same command, IPv6 OSPF1 area 0, right? And this should also establish a neighbor adjacency. And so, again, it was interesting that these instructions were here. However, you could hit 100 out of 100 without actually doing anything for this step. That said, once you came down to verify your access here, you would have run into issues. And so we wanted to make sure we got that on there. So now let's check again. Let's take a look from PC1, and hopefully that command is still in there. Good. Okay. now let's try to ping and take a look at that. Okay, great. So now we've got that access taking place. So remember with that IPv6 OSPF v3, you want to make sure that not only do you do the global configuration steps that you're looking to do, your router ID, the process ID, and even when you're doing your passive interfaces, you need to remember to go into the individual interfaces and enable OSPF as well. All right, so this is an awesome activity right here. A lot of things pulled together from the first 3 courses, and it really focused on OSPF. I'm going to go ahead and do the EIGRP one next, and I hope that you have found this helpful, and that maybe you've learned a little bit more about OSPF, NAT, and a lot of the things that we worked on here that you didn't know before you watched this activity. All right, thanks a bunch, and have a great evening.